So if you write lim equals 4, right, that's like saying went to the store. Right, that's an incomplete sentence. It doesn't give a complete thought. Right? Went to the store is not a sentence. Like, who went to the store? What's the subject? So you write something like lim equals 4, that's basically meaningless. I know there's a limit involved. I know there's a 4, but limit of what? What do we, limit of what? Where is x going? So also, if you just write like this, that's also wrong. Limit of what? Who went to the store, right? So the limit notation, you have to have, you're saying we're doing a limit, you specify what x is doing, you specify what function we're talking about, and then you give the result. And all of those components are essential. We checked from the left, we checked from the right, and we got the same result either way. We got 4 both times. So these are called one-sided limits. So lim x goes to 2 from the left, f of x equals 4, and let's practice my written communication here. And limit x goes to 2 from the right of f of x equals 4. These are called one-sided limits. Okay. Now, since they agree, we get the same result. This means we have a two-sided limit. Which is often just called a limit, but in this context, we can be specific and call it two-sided. So the limit as x goes to 2 of f of x equals 4. Or if we want, I don't have to write f of x. I can be more explicit and say the limit as x goes to 2 of x squared minus 4 over x minus 2 equals 4. Okay? So this is more of a metaphor or analogy that I use to kind of get the point across. While not technically 100% accurate, conceptually, I think it's helpful to think of it this way. I think of this is what f of 2 should be. I'll put should in quotes. Okay. So the limit is entirely about what is the behavior of the function nearby. So close to x equals 2. Remember, f of 2 is not defined, right? We get 0 over 0, not defined, we don't get a result. But near to, for input values near to, what are the output values like? What's the pattern? What's the behavior? That's entirely what the limit is about. What is the behavior near that input value? Sometimes the function value f of 2, with a different example, will be equal to the limit. Sometimes it's different. It depends. I think probably in the textbook, let me pull it up and look real quick. I don't know if it's given in this section or in a later one, but there might be a table of the different possibilities. I don't think it does that. Okay, that's fine. That's fine. But basically, you can have well, so for any function, so for any function f and a number, let's say a, right? So you can have that f of a exists or not. Let's say let's suppose the limit exists. The limit as x goes to a of f of x equals L. Then, because if the limit doesn't exist, that's something we haven't gotten to yet, but if the limit doesn't exist, then none of this would matter anyway. Then, well, one option is f of a doesn't exist. That's a possibility. Okay. Or you could have f of a exists, but f of a does not equal L, right? The limit exists, the function exists, but they're different. That can happen. Remember, the limit as x goes to a of f is not f of a. Sometimes they'll agree, other times they won't. And then that's the other option. F of a exists, and a equals L. So those are the three possibilities. Provided the limit does exist, then these are the three possibilities. Okay. Okay, so let me see, what should we do next? Let me pull that textbook back up again. Yeah, so we've done this numerically. Let's do this visually. Oops. And after we do this visually, we'll do this algebraically as well. So we're going to depart from this example. We'll come back to it later, but I want to depart from this example for now. If I just make sort of somewhat random graph. Okay, so let's say 1, 2, 3, 4, 6, 7. Let's 1, 2, 3. Say -4. 1, 2, 3. Say 4, and then 2, say 4. Okay. I'm going to pick a couple of points to look at explicitly. Okay, so there's just sort of a random graph. So when we deal with limits visually, it's usually pretty easy once you get the concept down. It's not as detail oriented as this, and you have to pick a bunch of numbers, do a bunch of calculations. It's visual. You just look at it. So what I want to think about when I think about the left limit, it's a 1, and here's 1 right here, right? Here's 1. So if I think about the limit as x approaches 1 from the left, think about it like you have someone walking along the graph towards x equals 1. So they're moving horizontally, and they're walking on the graph, so they're following it. Their height is based on what the graph is doing. So this person, I'll change colors here. This person gets closer to somehow they're getting shorter. I don't know why. But as this person gets closer and closer to this point here, they're following the graph, their feet are going to end up at height level 2, right? When they get to x equals 1, their feet will be at y equals 2. So we'll say that the limit, and I guess I'll put it down here. Yeah, I got some room here. The limit as x goes to 1 from the left of f of x equals 2, okay? And if I want, I could say 2 from above. Because notice at the end of the trip, the person goes down the hill a little bit. So their feet are at like 2.4, 2.3, 2.2, 2.1, right? So they're approaching 2 from higher values when they get close. There are lower values over here, but when you get really close, the value is shrinking as you get closer and closer to that location. Okay. And again, sometimes, often, we won't bother saying that, but for this example, we'll go ahead and say that. I think in the web work assignment, you're not going to do that. You'll have like an entry blank, and you'll just put in 2, and you won't do like 2 superscript plus. You wouldn't do that in web work. There might be some problems. Again, there are some new ones I haven't seen yet. There might be some that ask you specifically, is this from above or below? But if you're just typing in an entry field, you just put the number. And the problem should have pretty clear directions. Okay, so from the right, this person is coming from the other direction, right? Can you even tell me what the limit from the right is? Anyone?
The limit from the right is 1.
Yeah, thanks, Clyde. I have a list here, so I don't want to I don't want people to stop coming to the Zoom calls, but I might call on people and ask, hey, what do you think? I might pick on Johnny. Hey, Johnny, what do you think? So yeah, 1, right? Your feet will end up at and you could say, well, it's more like 0.9. We'll say 1, right? Close enough. So yeah, the limit from the right is 1. So the limit as x goes to 1 from the right of f of x is 1. Now, does it look like this is from above or from below? Anyone? Bueller? That's an old joke. Maybe some of you don't get. It's 50-50.
Bueller. That's an
Oh,
old joke. Maybe.
yeah. So yes, this one's kind of hard because you could say, well, is the graph is it going down and coming up, or is it just coming to a rest down? So it's maybe when I'm drawing by hand, it's maybe subjective. It's kind of hard to tell, right? Let's say that it does this one, that it goes down, and let's say that the low point is actually like right here, and it just slightly comes up after. So let's say from below, okay? If we had like a computer generated graph, it'd be a lot more obvious. Or if you had a function, you had a formula, you could determine more carefully, right? Like if you had this numerical table, this is definitely from above, right? Because, well, these numbers are all above 4, so we conclude, oh, it's from above. When you have a graph, that's not necessarily always so clear. But again, as I said before, we will typically not worry about above or below in the output. Sometimes we will, but typically we won't. Okay. So I'm kind of I have to erase some of these guys because it's a little bit in the way. So this was going that way. I'll change colors here. What about going the other way? If I follow this up, as I get closer and closer, because there's an asymptote there, as x goes to 3, where is the y coordinate going?
As x approaches 3, the limit is positive infinity.
That's pretty close. There's a minor error. So let's write that down, and I'll give everyone it. When someone makes a minor error, it's a good opportunity for everyone to think, okay, what is the error? So let me write this down. As x approaches 3, the limit, we'll just say y approaches positive infinity. Okay? Or if we want, we can write lim x goes to 3 of f of x equals infinity. I don't have to put plus infinity, but you can. You just don't need to. So just take a minute, and maybe some of you see it right away, maybe not. Think about what is wrong with this, and it's based on the graph. Sure, cool. Do you see what was incorrect about that?
Yes, as x approaches 3 from the left.
Exactly. Right. We're doing from the left first. We'll do from the right second. So I should say, get rid of that. Let's say a little superscript minus sign to indicate that we're coming from the left.